Ladies and gentlemen, welcome the moderator of the next two sessions, Patrick Tucker.
Hello, I'm Patrick Tucker, Technology Editor for Defense One. Welcome to our afternoon panel, Precious Space, A String of Satellites and the Future. Joining me virtually, Aarti Holla-Maini, Secretary General EMEA, the Satellite Operations Association, joining from Brussels, and Mr. Paul Jaffe, Electronics Engineer at the US Naval Research Laboratory, joining virtually from Washington, DC. Welcome to you both. Quick reminder to our audience, we are prepared to take questions via the GLOBSEC app. So we have a 20-minute session. We do ask your questions to be brief and hope to be able to get to a few of them in this session or perhaps the next one. So let's get started. The last several years have seen an explosion in private space activity, very exciting new business models around constellations, ever smaller, less expensive satellites, but we've also seen some small satellite providers grapple with great financial difficulties, and we have seen rising geopolitical tensions surrounding space. So let's start with you, Aarti. What are the major problems facing the satellite industry right now, and what role does the private sector play in overcoming them?
Thanks very much, Patrick. It's a pleasure to be here. My name is Aarti. Just to say, so the major challenge, I think, for our sector right now is the perception of the relevance of the industry to the fast-changing telecoms ecosystem, which now is starting to embrace 5G and even thinking about 6G. If the fundamental role that satellite has to play in our daily lives directly or indirectly is not understood, then policymakers are going to fail to tap the unique strengths of this technology, such as supporting the move towards decarbonization or leveraging satellite as the great equalizer that it is between haves and have-nots, or even looking to the future, enabling global quantum key distribution for secure communications.
Let me turn to you, Paul. We've seen tremendous diversity of satellite constellations over the last couple of years, and new emerging technologies play a big role in their design. Give us a sense of how satellite design in the next 5 to 10 years differs from even what is cutting edge today. How does innovation play a role in future satellite design?
Certainly, Patrick. Thank you for the opportunity. We've seen a lot of the growth recently because the industry is finally starting to realize the benefits of mass production. You know, for decades, satellites were these sort of one-of-a-kind, artisanally crafted creations, and now they are truly rolling off assembly lines, and that's one of the major factors that's brought down the cost. We also see the promise of the launch vehicle providers like SpaceX and Blue Origin that do truly seem to be on a trajectory to make space access more routine. A lot of the services that we've come to enjoy from satellite systems, communications, and navigation may even be further augmented in the next 5 to 10 years by that of energy. If you can imagine a system where, much as GPS completely revolutionized how we do navigation, where pretty much everyone listening to this, I'm sure, has at least one GPS-enabled device, there's a possibility to do the same thing for energy, where we might have a constellation of satellites in orbit that would collect energy and be able to distribute it globally.
This is fascinating to me, especially when you consider the history that the US Navy played in the development of the first geopositioning systems in space. The reason we have GPS is because some folks at the US Navy wanted to figure out how to position in the sky the Sputnik satellite, and they reverse engineered that and came up with the global positioning system that we today rely on. Not just to figure out where we are and to figure out where militaries are, but for timing functions related to financial transactions all across the globe. Hugely important constellation. So that brings up another question. Space is becoming increasingly essential, not just for military activity, but also for more and more economic life, more and more civilian life, and really the functioning of our interconnected global society. And that leads to an ever crowded space, especially in low Earth orbit. So what, if you will, Aarti, how can the international community further help to mitigate the threat posed by space junk and ever-crowded satellites, especially in low Earth orbit?
Thanks, Patrick. That's a hugely important question. I think management of the overall space domain should first and foremost be a public sector responsibility, and it is a huge challenge. We are in a phase today where private sector technical capabilities to launch new missions far outpaces the ability of regulators and governments to provide foresight and deploy governance capabilities. Things that we need to look at in terms of future actions are the maneuverability of assets that fly above 400 kilometers because they don't burn up themselves, designs that minimize risk to other operators, like end-of-life actions like removing all stored energy, decommissioning LEO assets within 5 years after the end of life. I mean, the current rules of 25 years is really out of date. And we also need to be able to assess the risk profile of LEO systems, which is not easy. I think what we really need is more investment in monitoring of the space environment in all orbits, and ensuring that existing tracking systems, like, for example, the European Space Surveillance and Tracking System, that they develop new capabilities to support emerging missions like in-orbit servicing.
Aarti, let me stick with you for a second, because you bring up something very important, which is the potential for international regulations regarding space. And where do you see an appetite in terms of which nation states, which governments, which international bodies are being most ambitious, pressing for an international dialogue on space norms, and where do you see challenges?
I think it's traditionally the most obvious spacefaring nations, but also the EU as a bloc is very, very proactive in this context. Right now, we're talking about the European, the EEAS, looking at a code of conduct and trying to push that and engage with other major governments, the US, Canada, and so on. But I think, this is a dialogue which is going on at the United Nations level since many years. There's a lot of activity on it. But what we need is to shift now from talking and writing codes of conduct and so on, really to norms and new rules which are actionable.
Well, let me turn to you, Paul. What does the democratization of the satellite industry resemble? And I'll also ask Aarti the same question, the democratization of the satellite industry, because I think that bringing private players into this discussion at an equal footing under that framework of international norms is really key. But we still don't really know what democratization of the satellite industry looks like. So can both of you speak on that for a second?
Yeah, certainly. So a major factor there has just been the plummeting cost of being able to implement space systems, right? So today, it is not uncommon for high schools around the world to be able to build their own satellites simply because a lot of these items you can buy off the shelf. And if you can imagine that high schools are able to operate their own space programs, certainly companies, even quite small ones, are able to do that. So that definitely amounts to the democratization of space. And the same factors that have enabled that are still going to continue radically reshaping the space industry as a whole. One of the big challenges that we'll see, I think, moving forward, and certainly this would be the case if energy from space via power beaming were to become a reality, is the regulation of spectrum. This is something that I know Aarti is very well versed on. But right now, spectrum is a finite resource, and we want to make the most of it, but there's not a ton of it available for a lot of these activities, and any of the new players, even with the democratization of space, are going to have to contend with that.
Aarti?
Sure. I think more countries than ever before are launching satellites. Any university science lab can afford to put up a satellite. There are reusable launchers. I mean, 10 years ago, nobody had even dreamed of that. And there's more money going into new satellite systems today than ever before. So we want to make sure that this dynamic environment continues to thrive. But I don't think it's a case of what does democratization of space look like in the future. I think we're looking at it right now.
Okay. Let me stick with you for a second, Aarti, because Paul brings up this question of spectrum sharing. It's something that a lot of people aren't necessarily aware of, but the electromagnetic spectrum is what governs the cellular universe, and it is bound by the laws of physics. And right now, the US military and other organizations are having a big discussion on how to create sharing of portions of the electromagnetic spectrum that are owned by militaries and sharing that with telecom providers to create 5G capability. Aarti, give us a sense of what are the technical and what are the policy issues surrounding spectrum sharing as relates to space?
So ESOA is very, very active in defending satellite spectrum and making sure that the satellite sector, satellite communications in particular, can continue to play their rightful role, whether it's in extending the reach of 5G networks, whether it's in enabling emergency and humanitarian communications, or whether it's simply in bridging the digital divide with education, healthcare, and so on. These issues, the challenge is that, you know, there is a geopolitical race to be the first to roll out 5G. Yet you have long-standing everyday requirements in more and more in the developing countries, but also in developed countries as well, to bring people online and to ensure essential communications. The challenge is to find the right balance. Satellite has had a role to play. It will continue to play a vital role. And that means that there is a need to preserve satellite preserve satellite spectrum, both for the satellite sector, but also for IMT, international mobile telecoms, including 5G and 6G in the future.
Let me take that same question to you, Paul, because I've been watching the U.S. military endeavor to do something that is very hard, which is create spectrum sharing realities to enable perhaps one of the most important enterprises of the 21st century, which is 5G capability, but also continue to provide very important coverage and communications to military units that are increasingly outspoken in their digital footprint. So how do you see this technical challenge of spectrum sharing proceeding from here?
Certainly. And spectrum is a fascinating resource, right? Because if you think about it, if you have the spectrum at a given unit of time, if it was not used, it's essentially wasted, but it's now in the past, right? So it's not comparable to a lot of other analogies we might use for natural resources. So the idea is that you want to use as much of the spectrum as you can all the time, and that leads to the spectrum sharing that you described. So there's quite a few different approaches, and definitely the demand for spectrum hand in hand with applications enabled by 5G, the large bandwidth that end users consistently demand is reshaping what things look like. There are very interesting new opportunities in this space. One thing that has gotten more attention recently is optical communications, which doesn't take the RF spectrum and can be highly directional. And then there's also quantum communications, which uses parts of the spectrum that we haven't used traditionally. So there are, I think, a lot of intriguing opportunities for how the spectrum can be used more optimally. And certainly people are looking at AI techniques for spectrum allocation and for spectrum sharing that will help us get the most out of this very important and kind of profound resource.
Can either of you talk a little bit? Yes, please, Aarti, yeah.
I think it's very important to remember that there are millions of people who rely on satellite communications, and those terminals are often unregistered. People don't know where they are. They could be TVRO, so television receive-only terminals, or it could be broadband communications elsewhere. So wherever satellite is relied on in this kind of ubiquitous manner, sharing is not possible. If we are talking about protecting large ground stations, which are predominantly used for uplinks, there, from a technical perspective, we can think about sharing. But the question of spectrum sharing is really limited by the laws of physics. There are some places where it's possible and others where it simply isn't. And as I said, it's a question of finding balance.
Thank you. And I think it's also going to be a big political discussion, too, just watching the conversation in the United States around Lidago and satellite companies that are very eager to, telecom companies especially, absorb more and more spectrum, and that perhaps comes at a cost of functionality for other users. And so we need to watch that regulation area, that political discussion very carefully. Can you comment, question from Slido, can you comment on dual-use government and private satellites? So thinking of private satellites that also offer some communications capability for governments. I'm thinking sort of specifically of the DARPA Blackjack program, but comment a little bit on how governments are increasingly turning to private satellite constellations for communications capabilities that used to be the sole domain of governments. I'll start with you, Paul.
Yeah, so this is sort of a classic technology development conundrum where industry, of course, tends to excel at developing systems and making them cost effective and operating them. But they can only do that once the initial technology has been developed and matured. So the model that we often see, and you made reference to this earlier when you talked about GPS, is the government's role tends to be taking those initial risks rather. You could think of it as prospecting, perhaps, whereas industry tends to excel when it comes to the mining phase, right? So to use the GPS example again, so NRL developed the first atomic clocks that were suitable for flying in space, and spaceborne atomic clocks are an essential element to create a navigational satellite constellation like the Global Positioning System. So once a government organization or a research organization like the Naval Research Laboratory develops like the first GPS satellite or the first few GPS satellites, it can be transitioned to industry. And at that point, we can start doing what you're describing, which is the government doesn't really want to be in the business necessarily of operating its own hardware and its own systems if it can get the same capability it needs by purchasing it from industry. And we see that increasingly for things like imagery and for communications, where it would be impractical for a government to buy all of the infrastructure needed to maintain communication systems for a conflict when it could just purchase it as needed instead of having a lot of unused capacity that would sit around all the time.
Aarti, do you have any thoughts on any regulation issues or international issues that might surround that future use by governments of private satellites that serve a private communications functions, but also increasingly serve military communications as well? Any reservations there or concerns?
No, I know that this is an extremely important market for many satellite operators. Often it's one of the prime markets is government services, because the commercial communication sector is so good at ensuring that their signals can be encrypted up to a military grade, and because they can guarantee, the required levels of reliability and availability that are required. No, I know that there is always some kind of pressure from European industry to encourage European governments to buy European capacity for that, because we see that in the US, for example, the government is always calling upon its own industry, and that is a source of that can support the technology advancement and the competitiveness of national industries. We do see some push for that in the EU, but nothing specifically when it comes to regulation and policy making around it. Thanks.
Yes. Okay, so we have time for one last question, and it goes to me. Thinking about the current geopolitical tensions surrounding space, the development of a new U.S. service branch, the U.S. Space Force, specifically to deal with those geopolitical tensions surrounding space and ensuring space access for the United States and U.S. allies and democracies around the world. What do you see as the biggest geopolitical challenge going forward in the next 5 to 10 years regarding establishing those norms that you just described? I'll start with you, Aarti. The biggest geopolitical challenge regarding the governance of space for the next 5 to 10 years?
I think the biggest challenge that we have is ensuring space traffic management, solid space traffic management, governance of space, and weighing that up with the race to have the first LEO broadband system, which is also, as you know, with Starlink, you have a huge government support there. The Chinese are trying to build their own system. You have OneWeb. Now the European Union is also trying to get in there. I mean, with all of these races going on, where, I think that space traffic management ultimately, because it requires international consensus and it's sensitive often, is unfortunately going to take a back seat. And I think that's a great shame.
Paul, to you, same question.
Yeah. This is a critical issue because, as you described, with the democratization of space, the increasing availability of space access to countries and other entities around the world, the establishment of these norms is going to be of the utmost importance. And this is something where definitely there are going to be implications, not just for low Earth orbit, where a lot of our systems are today, but expanding further outward to cislunar space, and the moon itself. We have the Chinese who have done remarkable technological feats, putting satellites in the Earth Moon L2 point and operating on the moon. We're going to have to face property issues and usage rights things for not just Earth orbit, but the moon and for cislunar space.
So a new infinite and expanding territory, not just for human activity, but also potentially for regulation. So I want to thank the two panelists, Aarti Holla-Maini from Brussels and Paul Jaffe from Washington, D.C. We will continue with the next session, Titans of Technology, Winning the Future of Defense, right after a short introduction video. So please don't go anywhere. We'll be back very soon.
Thanks, Patrick.